Hello and welcome. The interrupt is a mechanism to communicate the occurrence of an event and take appropriate action to handle the event while the microcontroller is doing something else. For example, you are baking a cake which takes 30 minutes to complete. Instead of checking the time repeatedly, you set an alarm to go off after 30 minutes when the cake is done. In the meantime, you can take care of something else. And when the timer goes off, you stop the task temporarily and take appropriate action, which may be switching off oven or like. Then you return back from taking care of the cake and resume the task you have halted. Something very similar is provided by the microcontroller in terms of interrupts. The Atmega 328 microcontroller provides 25 different interrupts. There are 2 external interrupts, 3 pin change interrupts, and interrupts from on-chip components like timers, watchdog timer, analog to digital converter, USART, etc. Each interrupt is assigned individual enable bits which must be written logic 1 to enable them. And global interrupt enable, that is I bit in the status register, is used to enable or disable the interrupts at global level. To enable an interrupt, the global interrupt enable bit and individual interrupt enable bit must be set. The instructions SEI, that is set global interrupt flag, and CLI, that is clear global interrupt flag, are used to enable and disable global interrupt enable bit respectively. Whenever an interrupt occurs, the current program execution flow is suspended and a special routine is executed to respond to the event. This special routine is called Interrupt Service Routine or ISR in short. The ISR defines the needed instruction to be executed on the occurrence of the event. ISRs are usually different for different interrupts, but there is an exception. We shall look into that in some time. ISR is defined by a programmer and must be tied to an interrupt. The microcontroller defines an address location where the program execution jumps when an interrupt occurs. This is called interrupt vector and it is uniquely defined for each interrupt. The collection of all the interrupt vectors is called interrupt vector table and usually placed at the lowest program memory. The interrupt vector is a 2-word long, that is 4 bytes for Atmega 328 microcontroller and contains a jump instruction with absolute address. The address points to the location of the corresponding interrupt service routine. The table shows the interrupt vector table which defines the interrupt vector for different interrupts. Interrupts have priority and define which interrupt will be handled first if 2 or more interrupts occur at the same time. Lower the interrupt vector address of an interrupt, higher the priority. Reset has the highest priority, then external interrupt 0, then 1, and so on. Here is the disassembly of the text section which shows the interrupt vector table. The interrupt vector table is placed starting with address 00. Note the address shown here is the byte address. The instruction at the address 00 is the jump to the address which holds the ISR for the reset interrupt. Then the address 04 holds the instruction to jump at the address EC which holds the ISR for the external interrupt 0 and so on and so forth. The interrupt vector table is usually placed at the lowest address of the program memory, which is the start of application section in the case of Atmega 328 microcontroller. However, it can be placed at start of boot flash section by setting the IV select bit in MCU control register. The reset vector can also be moved to the start of boot flash section by programming the boot reset fuse. The placement of the reset and interrupt vector table can be configured using boot reset fuse and IV select, that is interrupt select bit in MCU control register MCUCR. If the boot reset fuse is programmed, that is the bit is written with 0, the microcontroller will jump to the bootloader address. If it is unprogrammed, that is written with the value 1, the microcontroller will jump to the start of the application section. When the interrupt vector select bit in the MCU control register is set, interrupt vectors will be moved to the start of boot flash section. The address of each interrupt vector will then be the address in the table added to the start address of the boot flash section. Let's look into the combinations of these bits and the placements. When the boot reset fuse is set to logic 1 and interrupt vector select bit to logic 0, the reset vector is placed at address 0 and the interrupt vector table for the rest of the interrupts start from the address 02. Please note the address referred here is word address values. So effectively the interrupt vector table starts from the address 04. The interrupt service routine can be placed at any address location. When the boot reset fuse is set to logic 1 and interrupt vector select bit to logic 1, the reset ISR is placed at address 0. Notice that in the earlier case, that is when the interrupt vector select bit is set to logic 0, the reset vector is placed at address 0, but in this case the interrupt service routine is placed at the address 0. And the interrupt vector table for the rest of the interrupts start from the boot reset address plus 2. The boot reset address is defined by the size of boot flash section. In the scenario shown here, the boot flash section size is set to 1024 bytes. Hence, the boot reset address is 3C02 in hex. When the boot reset fuse is set to logic 0 and interrupt vector select bit to logic 0, the reset interrupt service routine is placed at boot reset address, that is the address 3C00, when the boot flash section size is set to 1024 bytes. The interrupt vector table for the rest of the interrupts placed starting at 02. When the boot reset fuse is set to logic 0 and interrupt vector select bit to logic 1, the reset vector is placed at the address 3C00 and the interrupt vector table for the rest of the interrupts follows. And the interrupt service routine of reset and other interrupts can be placed appropriately. With this, I conclude this lesson. In the next lesson, we shall discuss how to instruct the linker to place the interrupt vector table at the specified address location. Till then, happy coding!